Hey guys, let's do it. Lesson check 8-3. Okay, so we have a right triangle, and it looks like this is our reference angle. So we'll label this opposite, and opposite the box is the hypotenuse, and the other side is adjacent. Now this is just saying don't completely go by looks like. The drawing could be off a little bit, okay? That's what not to scale means. So what would be angle X? So when I look at what I have here, it looks like I have 11 to plug in for adjacent, so I could plug in 11 there, right? And I have 20 to plug in for the hypotenuse. So I need the cosine. So the cosine of an angle is adjacent over hypotenuse. And my angle here they called x, so I'll plug in x. And for adjacent, I'll plug in 11. Hypotenuse, I'll plug in 20. Nice. Okay, so this is how we set it up last class. And now how do I get x by itself? I'm going to take the inverse to both sides. So the inverse of this, and there's not a lot of room here, so I'm just going to use my eraser and scoot it on over. The inverse cosine of 11 over 20. Okay, so the inverse cosine of cosine just undid what we did, so that will give us x by itself on one side, which is exactly what we want. And now we have to figure out how to put this in our calculator, so let's take a look. All right, I'm not using the same calculator you have in your classroom, but it's kind of the same thing. What is our ratio? And our ratio is 11 over 20. Okay, so we've got 11 over 20. 11 divided by 20 is the decimal 0.55. And I can't take the cosine of that. I need to take the inverse cosine. So I need to hit the second button. Yeah, and then this cosine of a -1, and I get my answer 56.63. All right, so I get 56.63. So I'm going to round that to 57. Beautiful. Now I'm going to show that on the calculator one more time. Again, how do I take the inverse cosine of 11 over 20? Well, I have to know what 11 over 20 is, so I'll do that part first. Clear it out. What's 11 over 20? I get 0.55. And then what is the inverse cosine? Notice I want to pick this button that says cosine -1, 56.63. Nice. All right, next question. Find the value of x. Okay, so it looks like once again I'm solving for the missing angle x. So if this is my reference angle, I'll label this my opposite. Opposite the box is my hypotenuse. So I hope you're thinking, that's why you pick sine, because sine of an angle is opposite over hypotenuse. And that's the information I have. Okay, so sine of an angle x is 12 over 15. So notice I get out my eraser because I'm going to have to take the inverse cosine of both sides. Let's give ourselves some room here, right? So the inverse sine and the inverse sine, I must do the same to both sides. And nicely, the inverse sine of x is just plain old x. So I need to type in the calculator the inverse sine of 12 over 15. So let's do it. Let's start. 12 over 15 is the decimal 0.8. And again, I need to make sure I hit second. Sine, it looks like sine to the power of -1, and I get 53.13. 53.13. So what are my choices? It looks like my best choice here is 53. Let me show you how you do that calculator one more time in case you missed it. We'll start over. What is my ratio? It's 12 over 15. So I take 12 over 15, enter, and then I can make sure I hit my second button, sine 53.13. Nice work. All right. What do we got for 3. So it says sine of blank, so that must be my angle. So I can call that A or X, it doesn't matter. I'll call it A, I guess. Sine of angle A is 5/19. How do I get this by itself? Again, I have to take the inverse sine of both sides. So the inverse sine of both sides leaves me with plain old A on one side and the inverse sine of 5/19 on the other. So let's use our calculator. 5/19. Let's clear that out. 5/19 is the decimal point 26. And I make sure I hit second sine. So that's sine to the -1. I get 15.26. So I got 15.26. What do you know? There's my answer. All right, question number 4. We have a right triangle and a reference angle. So I have my opposite side. Opposite the box is my hypotenuse, but nothing's here, right? And then the side I haven't labeled yet is adjacent. So I need to find the ratio that uses opposite and adjacent. And I hope your brain is thinking, Oh yeah, it's tangent. The tangent of x is opposite over adjacent, TOA. And the tangent of x is then opposite 16, adjacent 7. So let's rewrite this. I can take the inverse tangent of both sides. So the inverse tangent of the tangent of x is just x. That's what I get on the left. What do I get in the right? Well, when I take the inverse tangent to both sides, I get the inverse tangent of this fraction, 16/7. So x is equal to the inverse tangent of 16/7. Let's try that on our calculator. So 16/7, enter. That's when I'm taking the inverse tangent. And again, I make sure I hit this second button so I get that inverse tangent. 66.37. Going back to our work, we get 66.37, and we're going to round that to 66. Last one. So we have a right triangle, and let's see what they ask. Ooh, they threw in a solve for the missing side. So that was last class, right? So a lot of the steps are the same. Let's try to remember how to do this. We use that reference angle. That'd be the opposite. Opposite the box is the hypotenuse. So you're like, oh wait, I already know I need to use sine. The sine of an angle is opposite over hypotenuse, and I've got something to stick in each of those places. So my angle here is 20, and I'm going to stick in 19 and x. Using that Lynch swap, right? What do we got here? We need to find x, but first we need to know what is the sine of 20. So going back here, what is the sine of 20? 0.34202, 0.34202, 0.34202. Now I can do 19 divided by 0.34202. 19 divided by 0.34202. 19 divided by 0.34202. Okay, that looks better. Enter 55.55. Let's take a look. I get 55.55. That would round up to 55.6. Now be careful here. Make sure you don't round too soon on the bottom. We want to round in the end. So when it says round to the nearest tenth, it doesn't mean round to the nearest tenth throughout the problem. You want to try to keep the numbers as big as possible until the very end and then round. Great job, guys. See you next time.